This is Skate, the third version of a robot I've spent 3 years building and breaking. It's hands down one of the most rewarding projects I've ever worked on.
Oh yeah.
In this video, I'll walk you through how it evolved and share the biggest lessons and design pivots that shaped it. The original robot was very experimental, 25 kilos, multicolored, and packed with old ideas that just didn't make sense anymore. Its hip and knee joints could output 130 Newton meters thanks to a cable differential that doubled torque without adding any extra weight. But assembling and tensioning those cables was an absolute nightmare. And 130 Newton meters flinging around a 3 kilo hub motor is about as scary as it sounds. So I fixed those issues in the next robot. Or at least I thought I did. Skate V1 turned out feather light at just 15 kilos, while still being adult sized. The hip and knees now pushed 80 Newton meters using a newly designed actuator that was 40% lighter than before. Paired with lighter, belt-driven wheels, the whole robot felt way safer. I got it up and rolling with traditional control, enough to balance, steer, and recover from light pushes. Then to take it further, I trained a reinforcement learning policy in simulation that could climb stairs, though I never tested that on V1 since there were too many mechanical issues. Namely, the built-in tensioner couldn't keep up with the cable creep in the differential and would eventually run out of travel. On top of that, the actuator gears were prone to shattering under heavy impacts due to reflected inertia. So I moved on to build Skate V2, switching to cycloidal reducers. That solved the gear failures but introduced torque ripple above 20 Newton meters. Around mid-2024, I noticed commercial quasi-direct drives starting to become more accessible. They were still pricier than my custom actuators, but far more torque dense. And best of all, no more assembling 136 parts per actuator, and no more trying to simulate nonlinear dynamics. So I phased out my custom actuators as well as the parallel differential. Which brings us to the current version, Skate V3. Now with arms, and a head. It's controlled through a Quest 3 VR headset, with a stereo camera that streams video for a first-person view. To control the upper body, I mapped the headset and controller positions to a digital twin using inverse kinematics. Once it looked good in sim, I tested it out on hardware. Each arm weighs 3 kilos and can lift 3 kilos. It's so fun to just mess around with stuff in all kinds of places. For the legs, I trained an RL policy with a full body model. On the real robot, it can balance, stand, move forwards and backwards, but when it tries to step, it starts violently oscillating side to side. My best guess is that the legs aren't laterally stiff enough in real life compared to simulation. So the sim to real gap is just too big for the policy to cleanly transfer. Looking ahead, I'll be stiffening up Skate's legs, swapping out the over-spec'd head actuators, and upgrading the wrists and grippers. Until then, here are some of my favorite moments from the last few years. Hope you enjoyed, and I'll see you in a bit.
This is a QR. And then you have to like actually scan the QR code and then
Come on, buddy, come on! Come on!
Come on!
Come on! Come on!
Yay! This thing. Yeah, like
Oh yeah.
a couple months.
Come on, buddy.
Let's go skate.
Yeah!